Deep learning has become a phenomenon which we cannot ignore. So a lot of empirical success, which brings up the interest of understand in a fundamental way why those methods work, why they did extremely well in so many applications. So to answer this question, we feel that we may look at this problem from different angles, and most likely the breakthrough is coming from the interdisciplinary activities. So those areas may include the statistical thinking, may include mathematical thinking like approximation theory in the applied maths, and may involve a lot of computational thinking, like computational math, the algorithm design, the overall complexity of those algorithms, and why some of those gradient descent-based methods are working well.
People are very, very interested. The scientists, and the pharmaceutical companies, the biotech companies, they are developing several methods, for example, for early diagnosis, for finding biomarkers, or like designing novel drugs that could be more targeted, more personalized, more precision medicine, right? For those to happen efficiently, we need to develop a method. Lots of times, so what has happened in the past, I guess, is there were a lot of trial and error methods just because there were nothing better than that. But people have understood the value of information. They understood the data sets that we gather from different assays, from different experiments, are extremely useful to guide us towards the right direction. So we don't have to throw dirt in the dark anymore. We can use those data to essentially help us move towards the right path.
The best thing about this conference was that I heard a lot of speakers from a lot of backgrounds. So I understood some topics from the statistical background, some from pure optimization background, and also computer scientists who work in extensive image data sets. So this was the best thing to look at it from different kind of point of views.
I've been able to, while I'm here, just learn more about deep learning in a more theoretical sense. At GTRI, we do a lot of applied research, but that doesn't mean that you still need that theoretical foundation. And so it was basically just like a research retreat for me. I had the opportunity to go deeper into the theoretical aspects of some of the algorithms that I will be applying when I return to GTRI. And I'm also really excited about the working groups. I signed up for the teaching working group, so teaching deep learning. I think that's really important, is being able to teach something before you apply it. And I think that the deliverables that we have from this particular working group will be something that will make a long-lasting contribution to the literature.
So when I look up for the program, I was more interested in the interpretation of the deep learning, because I work as a graduate assistant where I lead consulting lab, and most importantly, I need to interpret my models. And we know deep learning is more or less a black box model. So interpretation is what attracted me to this deep learning workshop.
I stumbled upon a deep learning meetup group actually, and I signed up for that, and they sent me the SAMSI link a few weeks before the program started, and I signed up for it. I thought this to be a great opportunity because it's right here. I have a couple of people I knew at UNC. I talked to them, and they have done SAMSI before. Greg Forrest is one of them, who has been, I think, in the organizing committee as well. So I talked to him, and he said this is a great program, and I said, oh, okay, I want to learn about the fundamentals of the program, because so I signed up. The reason was to understand the basic methodology part, because we know the data that we get from patients, the data we get from drug trials are not homogeneous. They are not, always simple and linear. So I wanted to first understand the methodologies so that I could actually then apply it according to the problem, the question we are asking.
Yeah, I think I think this is a definitely productive week. We have 3 days of lectures. I think those lectures are really high quality, and I think they are very clear, and they represent the advanced research, the frontiers of those research areas. And also at the same time, because the speakers, I think intentionally, they are also thinking about how to apply their theoretical development towards generating a solid foundation for the deep learning. So they also already start across the disciplinary boundaries to try to connect with other disciplines. So I think the talks are very inspiring and kind of pointing to the direction that we're aiming at. And also, I interact with some of the participants. So far, the responses I got are very positive. So I think this is a productive week.
So this workshop is very good workshop. I was so happy to see more statisticians coming on board to contribute to the deep learning, machine learning community. So I will encourage everybody who is interested in the deep learning or machine learning to come on board, and let's join hands, because it's here to stay, and we have to make sure that it's going to be more efficient. And how do we make it more efficient if the statisticians, the computer scientists, and the engineers come on board? I think we can all make it happen.